company produce rows of materials. Okay, the rows of process 1 are 3% detected, and the rows of process 2 are 1% detected. Process 1 produce 60% of the company's output. Process 2 process 40%. Now a row is selected at random from the total amount. Given that this row is defective, what is the conditional probability that it is from process 1? All right. So, roughly speaking, what kind of information you have? Now, here is the probability. I use capital 1 to stand for the product is coming from the process 1. So, this probability should be, according to the exercise here, it should be 60. Okay. And another probability is this guy. So it should be 40% instead. Okay. So here we got these two numbers. And now you were asked to find out probability that, okay, the conditional one, we would like to see whether the product is coming from I, given that the product is defective. So I use D to stand for defective. Okay, and then we have the following information as well. So for the first sentence, they told you that the process 1 are 3% defective. So that means it is defective given I is equal to 3%. And while the other way around, we have probability that defective given that it is coming out from the process 2, it should be equal to 1%. So here are all the numbers, and we would like to find out the corresponding conditional probabilities. Okay, the conditional probabilities. So how to find it out is a very standard exercise. As I already, even before the midterm, I already told you, remind you how to tackle the base, how to use the base formula to tackle this kind of conditional probability problem. All right, and the only difference is about the phrasing and the use of symbols. All right. So what you have to do now is to find out P, I given D. So in other words, it's just the same as finding out PD given I. 1, sorry, it should be 1. And then finding out P1, and then divided by what? Divided by PD given 1 and P1. Together with the other part is PD given 2, P2. Okay, so here we got what? So this guy is D given I. So what we got here is 3%. D given, so here is 0.03. And together with the proportion PI is what? 60%. So we got 60%, 0.6. And here the other way around, we just copy it. And for the other guy is 0.6. 0.6, 0.4, and together for the other one is 1%. So it should be 0.001. Okay, so that turns out that it should be 3 times 6 over 3 times 6 plus 1 times 4. Okay, so here we've got 18 and over 22. So it's done. Okay, you can simplify it as well. 11 and 9. Okay, it's done. All right. So roughly speaking, I expect you guys can get the marks in a very short time. Okay, and how about the other tools? As I said, these are is also a set questions to me. Okay, a company provides the earthquake insurance. Okay, this sentence is useless. You only have to care about is when the variable x, the premium, x is modeled by this probability. Okay, this is the probability density functions. And here is the y, here is the density function as well. And suppose they are independent, find x, z equal to x over y. Okay, so how to find it out? So, as usual, what did you learn to find out the beta distribution? What did you learn to find out the F distributions? At that time, we try to write out the first step, find the CDF. Okay, find out the CDF first. So means we would like to find out probability z less than or equal to small letter z. And now here we got probability x over y less than or equal to z, right? Okay. And then we have probability here x less than or equal to z times y. Okay. And we are given that x and y are independent. So what we do is just integrating all possibilities. Now, first of all, the range of y is in between, well, just the positive real numbers, x as well. Okay. And according to the restrictions we have here, the restrictions that we are given here is x is bound to be above by this guy. Okay. So why don't we try to integrate out over y first from 0 up to infinity? So we integrate y at the outer shell. And how about for the inner shell? For the inner shell is integrating from 0 up to zy. And then we're integrating against the joint density functions, fx, okay, and together fy dx. So this is the way to find out the PDF. All right. Okay. Z, well, no, here we already got it here. Okay, so that z is here. All right, so how to find out the PDF? This is the CDF, right? Okay, but anyway, we try to tidy up this term and plug in the definitions. So what the definitions is here? We have, this is the density functions. These are the density functions, okay? All right. Okay, so we just plug it in. Here is what y over 5, okay? This guy is, this is y, sorry. Y e to the y over 5. 5 here, 1 over 5 here as well. And how about the other ones? We got this guy as well. So we have x e minus x over 5 square. So at the end of the day, here we got this integral, integrating from 0 up to infinity. Zy 0. And then we have 1, 2, 5 outside. Okay, we have 1, 2, 5 outside. And together we have x e minus x over 5 times e minus y over 5 dx dy. Okay, so how to find out the PDF? So this is the second step. To find out the PDF. How to find it out? Now, the best we can do is just differentiating z respect to z of this probabilities. Okay, and then we got what we want, right? So in this case, we just differentiating this guy, this integral, using the Leibniz rule. Okay, so what we got? We just keep everything unchanged for the first integral and together with the constant at the front. And then we differentiate this guy is just the same as plugging in this upper term into right in place of x. And together applying the chain rule as well. So we have an additional y. Okay. So here we got zy e minus zy over 5, right? And together with the chain rule, we got y. So here we got y e minus y over 5 dy. So here is the overall stuff. Okay. All right, so we take out the z. Z is totally independent of the integrator. Okay. So here we got 1, 2, 5, 1 over z integrating from 0 up to infinity. And then we have y square. We got 2y here. And combining the z as well. So we have e to the power 1 over 5, 1 plus z, and then y. Okay, is that all right? dy. Okay, I'm done. This is 2, okay? This is 2, not z. Okay. All right. And now what's the next to do is deal with this integral. And as always emphasize, in this class, even though I may ask you to deal with the integral, at the end of the day, you actually don't have to. You just recall your old friends coming out, gamma. Okay, and then you can write down the answer, right? I repeat that again and again and again. Okay， 不如咁啊，當然我諗你哋而家望住喺度咧，都應該有少少人擘大口得個窿，都應該都唔係嘅，應該都可能識做嘅，唔使驚，有分嘅一定。OK， 最重要嘅嘢咧，應該係同聽錄音嘅人講係咩咧？點解會呢啲唔識做咧？點解會將兩個 density 相除咧？主要原因咧就係因為佢將以前嘅 text paper 或者 midterm 咧，全部淨係背晒啲答案，背晒點做，但係其實從來都唔明嘅。OK， 有一班咁嘅人嘅，嗰班人咧大部分都唔嚟上堂添嘅。而今次咧，因為我聽到你哋成日都話啲題目咁似，我不如改佢啦。我真係改一條，我改一條啫，其他後邊嗰啲喺 exam 嗰度出㗎，其他後邊嗰幾條 ，OK， 我就改咗呢條，咁改咗呢條咧就見真章啦。Okay. All right. So here what we got, we integrate this guy. Okay. We got z here. Bear in mind we got z here as well. Okay. So how we get this guy? Integral from 0 up to infinity, y squared. And then we've got here this guy, right? So we try to tidy up this guy, e to the power y over 5 over 1 over z. I try to rewrite in this way. All right. And then we have dy here. So we clean up everything. All right. So how to make up it to be a gamma density? We have to tidy this guy up. So first of all, we got this 2 actually is equal to 3 minus 1. Okay. So we have gamma 3 here. And together, this is our theta. All right, so we have 1 over, okay, and then 5 over 1 plus z to the power 3. So adding this term, we got 1. Or in other words, you have integrating from 0, y squared e minus y over 5 over 1 plus z is just equal to gamma 3, 5, 1 plus z cubed. Okay, in case you forgot what it is just 3 minus 1 factorial. So this is just 2. Okay， 喂，唔緊要啊，你計唔到唔緊要啊，寫咗一大堆，你俾個 C 我都仲得。OK， 我最多扣你1分嘅啫。OK， 但係你話去到呢步咧，我基本上都想俾滿分㗎啦，得唔得？有冇問題 ？So we have z term here, and also we got z here as well. Okay.